Okay, Kingsley, I think we can start.
All right. So hello, everyone. Welcome to the CESAC Pin Talks. And I will be the host of today's talk. And my name is Kingsley Wu, and I am a PhD candidate at UC Riverside. My graduate research focuses on applying molecular modeling approaches to investigate protein and drug binding. Specifically, I use computers to simulate protein and drug interaction with each other, as well as machine learning to predict their interactions. Other than science, I'm also mentor undergrads and junior graduate students for their research, helping them to get to know the big picture of their projects. So mentoring and instructing are also my personal interest. Hence, today I am volunteering for Pink Talks to help educate our younger generations. We hope to leverage CESAC's excellent network of scholarship awardees to better serve our community, which is why we start the Pink Talks series this year. The Pink Talks stands for Professional Insights for Next Generation's Talk. And we are inviting seasoned professionals from various backgrounds to share their personal stories as well as their insights of the current trends in their field with us. The talk will be about 1 hour in length, and we'll begin with an interview for about 15 to 20 minutes. Then we will spend the majority part of sessions taking questions from the audience. During the talk, please feel free to type your questions in the chat box, and we will get to them at the Q&A sections. But before that, let's welcome our president of CESAC, Guo Chenxi, to give us a brief introduction of CESAC. Chenxi, take away.
Yeah, thank you, Kingsley. So, hi everyone, my name is Chenxi Guo, and I'm currently serving as the CESAC president for term 2022 to 2023. CESAC stands for the Chinese American Engineers and Scientists Association of Southern California, and it was founded in 1962, and actually this year we just celebrated our 60-year anniversary. CESAC strives to serve the Chinese American scientists and engineers community, and we host many events such as our annual convention, technical symposium, business forum, tech salon, you name it. We also have programs such as the CESAC scholarship and STEM essay contest to cultivate the next generation of scientists and engineers. We have distinguished speakers and awardees come to our conventions to give speeches and accept our awards, such as the Nobel laureates you see here, and other elite professionals like former Secretary of Transportation Elaine Chao, movie director Ang Lee, actress Lisa Liu, and more. So, since 1984, CESAC scholarship program has been running for almost 4 decades. We are glad that we were part of their journey to pursue their dreams. Many of our scholarship alumni has become respected experts in their fields, such as professors, doctors, investors, entrepreneurs, executives, directors, managers in tech and finance firms, and many more, lawyers, government officials, you name it. So that's why we started the Pink Talks, and we hope that our family, CESAC family, can come back and provide us with their life stories and their experiences, and so that we can carry on the legacy. That's what I have. Thank you, Kingsley.
All right, thank you, Chenxi. So today our speaker is Dr. Xiaochen Liu. Xiaochen is a machine learning engineer in Avon. Avon is a fintech startup that helps people to get easier access to capitals. He built the machine learning backends for Avon's user growth and evaluations. Before joining Avon, Xiaochen was a senior research scientist at Meta, aka Facebook, where he worked on improving deep neural network recommendations models for feed and reels. And Xiaochen received his PhD degree in computer science from USC, advised by Professor Ramesh Govinda. So Xiaochen, I know that I have briefly introduced you to the audience, but I think we would like to know more about you. So can you please tell us more about yourself? For example, your education background or professional background, please?
Sure. Yeah. Thanks for the introduction, Kingsley. Hi, everyone. My name is Xiao Chen. And as Kingsley just introduced, I'm now an machine learning engineer at Avon. So back to my education background. So I get my bachelor in science from Peking University in Beijing, China. And in 2014, I started my PhD at USC in computer science. So where I mostly research on computer vision systems. And I'm very lucky to receive the CESASC Scholarship Award in 2015, where I get a chance to meet with a lot of awesome PhDs and also leaders in different industries. So basically, it's pretty smooth in my PhD life. And later on, I just joined Meta after graduation as a research scientist. So at Meta, I still work on machine learning related problems, but instead of computer vision, I mostly work on the recommendation neural networks. So after about 3 years at Meta, and recently I changed my role, and I joined a very early stage startup called Avon, and which is a fintech company where we believe we can leverage the technology and machine learning to help users to get easier access to capital and providing them with a much lower interest rate as a credit card. Yeah. So this is basically my background.
Okay, I see. So so before we go to the very professional talk or discussion, I think I personally would like to know more about your working environment, since you just introduced that before your current job, actually you work in a Meta. So we would like to know what will be the work environments or something like a very typical schedule that those software engineer or research scientists like you will look like.
Sure. Yeah, so I can introduce both the life at Meta and the life at startup. Basically, it's quite similar for my both roles. So mostly because it's after pandemic, and most of my days are working remotely with my with my laptop, and the way we communicate with each other is usually through online chat or a Zoom meeting or whatever, online meetings. So, but people still find it's more convenient to exchange some ideas in person. So usually we will have 1 or 2 days per week to meet in person, making discussions. Yes, so something like that. And in terms of the size of the team at Meta, or probably most of the big tech companies, each team will have around 8 to 15 people, and each people will work on some specific tasks, especially as a research scientist. So we will have our own field to research with, and but we will still communicate with each other on the new ideas. And at Avon, because it's still very early stage, the whole company only have about 20 engineers. So usually, people will just form a bigger chat thread discussing very important issues. Mm-hmm. And for each individual engineers, it will be more, they need to take more leadership in their field because they will be the only expert in that area. So yeah, so that's basically it.
Well, it's quite similar as I am with right now, but I'm working in a lab, no company at all. Okay, so yeah,
it's similar. Right.
Yeah, I also work from home most of the time because I don't go to the lab to do any work like a wet lab chemistry, but I focus more on the computer simulations. So mm-hmm. Yeah, so I can mimic the environment. So okay, So you mentioned that you work as a research scientist in Meta, and now you are a machine learning engineer. And it seems like these two roles are quite similar, but somehow different. So, but all the backgrounds are based on the computer science. So for those who are interested in working in a computer science major and possibly enter or become a software engineer, what will be the workflow like in the research scientist, and what will be the difference between the research scientist, machine learning engineer, and a software engineer?
Yeah, very good question. So for research scientists, not only at Meta, but also some industry labs, so your work will be more like a PhD, like what Kingsley is doing. So you will need read some papers to understand the state-of-the-art technologies and to see how to directly apply to your company's code stack, or making some tweaks, or like just innovate something new. So that will be more like on coming up with new algorithms, but will less on the coding part. So, and the expectation for research scientists will be like have a longer delivery period. For example, like one research project could be like 3 or 4 months before getting any real impact. However, on the other side, for regular software engineer, you will be mostly like shipping code to build things. So that means you will need to move faster in terms of the amount of code, and also like it's you will have like more frequent checks with the whole the production. For example, like you deliver different features, so then the next day the users could see what we have changed. So both of things I have done. I have done both, and I feel like they have different pros and cons, but both will be like a very cool roles if you work on if you are majoring in computer science and later on like becoming either of them.
I see. Great. Thanks for the answer. So now you move from Meta to Avon, a startup company. And can I say it's a kind of fortune that you kind of get rid of this like a high-tech company laid-off wave, because as far as I know that you were not in that layoff wave, right? Because you jumped
I hope I was, so I get some serious package.
Okay.
Yes.
Okay. Well, all right.
Just kidding.
Okay. All right. Good. So for your current situation, I mean, the company, can you tell us a little bit more about what you are currently working on as a machine learning engineer in Avon?
Yeah, sure. Yeah, but before that, I can briefly introduce like what I have done at Meta. So as you know, like Meta is a service of recommendation, right? They recommended your friends update. They recommend different short videos. Right. So the engine behind this is a very complex neural net model. So we are the team that in charge of this model. So it will be a pretty critical role and a very fundamental team towards the product success. So my daily routine will be mostly see like where the improvement we can do to the neural network in terms of like both mathematically and also on the code level. So, and we will also work with our product teams to monitor like how the model is working, like what improvement we can do. So right, so that's on the Meta side, and for the startup, it will be more like a software engineer style. So I need to take charge of basically everything. So at Meta, you have a very solid and scalable framework for you to train a model, to deploy a model, to monitor a model, right? But at startup, you basically have nothing. So except some open source solutions at like AWS APIs. So that means like I have to move quickly to build up everything. For example, like the how to orchestrate different AWS instances for model training, how to build the data pipelines, how to select the right models, and also how to evaluate, how to ship A/B test, how to make decision, like how to iterate. So the scope is, I would say, much bigger than what I did at Meta, but definitely it will be more faster paced, and I would say like less would be less state of the art because it's so early stage. But our first priority is to make sure everything runs correctly. Yeah,
I see. Okay. So it sounds to me that in a startup company you will take a lot of responsibilities, right?
Yes.
But in Meta, since everything already been taken care, so you would just do whatever your role is assigned to.
Yeah,
right?
it's you just go deep.
Okay. So is there any significant difference between this kind of a giant company like Meta versus this startup company like Avon? Of course, the people-wise, you have like thousands versus like 20 that you just mentioned, right? So, any other differences you can feel on outside of the professional?
Yeah. So first difference is work-life balance. So even though Meta is already have a not good reputation for its work-life balance, I will say like the startup will be like the double of it. So because you are the sole owner of that field, you basically have to work longer to make sure everything works, and to solve more problems in production. So definitely much worse work-life balance. But like you, right. So that's one thing. And also like the way for people to collaborate is a little different. So at Meta, like, although we want to move fast, but there are still some formal rules you have to follow when you want to reach out to cross-functional teams, right? To approve, to get like PM approved, to get the designer reviewed. But at the startup, it will be like everyone getting to a pool, and whenever there's a problem comes in, and like everyone just look at together. So and the third one will be so will be the problem to solve. The at Meta, like you just need to like tackle down this single mathematic problem or like this single neural net module. But at a startup, you just build everything, as what I mentioned.
I see. So that's the difference. Any other similarities you can tell us a little bit?
Yes. So I would say like both of my roles are still like both of them are working on like recommendation. So at Meta, like I modify and train neural networks to recommend the right videos, short videos to the user, and also target the right user we want to distribute those content. And at Avon, like we want to use machine learning to find the right user we want to promote our credit card and our financial solutions to, and also provide them with the right, let's say, interest rate that matches their financial capability. So basically, it's doing it's pretty similar like domain.
All right, thank you. So I read a little bit about your PhD work. So you actually focus on computer visions, but now your work are heavily rely on recommendations. So why did you move from computer vision to recommendations? Can you tell us a little bit about each of these two, Phil?
Yeah, very, very good question. So first, I want to briefly introduce the difference between computer vision and recommendations. So computer vision, as you can imagine, is to teach the computer, the machine, to understand what it sees from the camera, like whether there's an object and what kind of the object is, and if that's a human, what the human is doing and who the human is. And that's computer vision tasks. And for recommendation, it's what we want to guess, like what the user likes, so we can efficiently retrieve the right content and distribute that to the user. So the major difference I would say is in computer vision, most of the time you have the ground truth, because if that's an apple, it is an apple. Like that's a ground truth. But on the recommendation side, there's no ground truth. You will never know what the user actually likes unless you are that user, right? So it will be hard. You can say like on recommendation, it will be to predicting a human mind. So it's much, much more challenging. And also you need to do that on a very, very scalable way. You are targeting billions of users, and how can you do that fast enough? So that's a major difference. And the reason why I switched from the first to the second is first is like after a PhD, I have done that for 5 years. I want to do something new. And another reason is for my understanding of our current age of internet, people sometimes call it internet web 2.0. So recommendation is fundamental to web 2.0. So you can see like what entry point when you access to the internet. First is Google search, right? Searching. The second is feed, whatever feed you get from TikTok, from Facebook, from Instagram. And third one is how you see business from ads. So all these three major drivers, they are based on recommendation. So we can summarize that like that. The recommendation is the core engine to drive the whole business of the internet at the current stage. So that's why I think it will give me a bigger scope and more things to explore. Yeah, so basically that's the two reasons.
All right, so interesting and a little bit kind of upfront. So saying that the machine learning and the recommendation algorithm are kind of popular in this current stage, and what will be the future trend you're seeing in your field, and what will you foresee to happen in the next about 5 to 10 years?
Yeah, so yeah, this is a quite broad question. I'm not sure if I am senior enough to answer that, but I will give my input anyway. So first is like we are seeing from my experience at Meta, we are seeing the recommendation system is making more and more social impact. So as you can imagine, like the problem with Meta is like back to 2016, the Cambridge issue, right? They leaked the user data, which probably changed the election result. So, and later on, like when we come to COVID, there is like rumors about vaccines, right? And also like different social issues, like about the racial problem and also the criminals. All of this, we're seeing like the current recommendation system is not properly handling that. It still needs quite a lot of human effort to label harmful content. And recently Elon Musk just reversed that on Twitter side. But yeah, so you can see it's pretty problematic. So how can we make this solve this in a more systematic way? Let's say, can we train much better neural network to solve this? So that's something. And another one is like, how can we improve the system so that it won't create an information bubble for everyone? Because that's actually splitting the crowd. So 10 years ago, like people are mixed, but right now you can easily tell if someone is left wing or right wing by their comments, and they are more and more separate from each other. So that's a problem that our today's big tech companies must solve, like Google, Facebook, TikTok. So they need to solve that, and the key is still recommendation, because that's what the problem caused by recommendation. And furthermore, like even broader view of the whole field, the machine learning or computer science, definitely AI will still continue to grow in the next decade. And we are seeing more and more exciting progress there recently, such as the stable diffusion, right? Everyone is using that to generate pictures. And also we can see a very thrilling involvement in natural language processing, and the generative AI can fluently communicate with people at some extent. So then the thing is, how are we going to integrate those things, new technology advances into our daily lives and make that beneficial to everyone's either work or their personal life? So that's the key challenge and gap we need to fill. And also, like, there are some new things coming up, like blockchains, and I know it's a buzzword, but I also feel like it will be something pretty important in the future. And how are we going to integrate that to our today's system? And that's also another like challenging topic.
Okay, thanks for the input. So what you just described to me are very fascinating and make me to think what kind of a skill, or at least in scientific field that, or any other courses we should prepare. I know that you graduate from Beijing University and PhD from graduate PhD with the graduate with the PhD degree from the USC. So I wondered, how did you prepare yourself for this kind of job?
Yeah, so good question. So frankly speaking, I think I'm one of the lucky dogs that I didn't spend that much effort in preparing a job. So instead, like every time, no matter it's internship or full-time jobs, it's just the company reaching out to me. So it would be more like I basically skipped all the application process. So and then, but one thing I think is very beneficial in my interviewing process is like my PhD experience gives like trained me a lot with the presentation skill and the critical thinking, which is also very useful when you go to the industry to do some extra work. And yeah, so for that, I really appreciate like the PhD training, like naturally just make me capable to handle that problems. And also like all my previous internship, like they're also related with computer vision and machine learning. So they also contribute to my resume to get me prepared for the upcoming full-time job.
All right. What surprised you? What makes you so interesting in this kind of field? Can you tell us?
So by surprise, you mean like why I choose to go to industry instead of academia?
Yeah, and then from like study from computer science major and then go to this industry with since you introduced, you have like a internship, right? And then you get lucky to be promoted or invited to this like high-tech company. So what surprised you when, or did you find anything interesting than when you joined this field?
I see. The major difference, right, from between the doing PhD and the actual work. Yeah,
That's
yeah,
right.
that's a good question. I will say, like on PhD, your focus is how to publish a paper, right? So then, like, you need to make your experimental environment clean enough. You need to clean the data, and you basically make everything perfect, so you can get a perfect result which beats other peers' result, and so you can publish. So I would say it's more like a toy or a proof of concept. However, like when you come to the actual work, especially at the Facebook scale, it will be much harder to keep that clean environment. So your data pipeline could break, and sometimes the logging could miss, and also it's a long chain of tools and framework from your model to the actual like result delivered to the user. So like if you want to make something work, you should not only like improve your model, and that's totally not enough. You have to understand like every piece before and after to make sure like you understand it, you make sure your change doesn't break anything, and you understand like how the user reacts to your change. So that's the major difference I learned about. Yeah, and
Right.
one more thing is, at PhD, you are usually just the sole warrior like in the field. You don't have to like chat much with others unless you are in a conference. But in any tech companies, that's usually like unrecommended. So you should communicate with others as early as possible, so people are aware of what you are doing, and also like they can give you early feedback, so your change won't break things, and you are on the right priority that aligned with the company's priorities.
All right, thank you very much. I think that's all the questions we have collected before our session started. So let's move on to questions from the audience. So please type your questions in the chat box, or simply raise your hand and our team will unmute you.
Hello, everyone. So right now you can unmute yourself or raise your hand. I see one raise your hand. So can you unmute yourself and raise your question? I see a attendee named A. Raise your hand. Can you please unmute yourself? So anyone else can?
No, we cannot. I was trying on my phone. We cannot unmute ourselves. You have to unmute her or him.
Okay.
Yeah.
So that sounds weird. Okay. So anyone who has questions, please raise your hand and ask to unmute.
Yeah. Or let's see.
Oh, wait a moment. Okay. That's my mistake. Okay. So everyone, right now you are able to unmute yourself, and I see the user, the attendee A. Can you unmute yourself right now? So anyone else has question?
You can type your question to Kingsley in the chat box if you cannot send it to everyone, or if you cannot unmute yourself.
Okay, to warm up, let me ask the question first. Xiaochen,
Sure.
so how do you utilize machine learning in your new job at Avon?
Yeah, that's a good question. So yeah, as I mentioned,
if it's confidential, you can.
Oh no worry, no, not confidential. Most of things are like we are using open source, so yeah, because we need to build things as soon as possible to make the pipeline work. So right now, like we bootstrap our user targeting model with the decision tree model, so which you even heard about, it's XGBoost. So it's a pretty efficient tree model that you can quickly bootstrap with like thousands of features and deliver some reasonable accuracy. So that's that's quite different from like my previous Meta experience, where like you do very like advanced like neural net tuning and trying different neural net architecture. Yeah. So yeah, basically right now it's one thing we are doing user targeting, and also we are using similar like tree models to identify like user fraud activities, because we are distributing a credit card, and so it's naturally there comes with fraud activity, and so we are trying to solve that problem also with a like decision tree model. But later on, like as we grow bigger, hopefully, so and definitely we want to try some more advanced models like neural nets.
Oh, thank you. Yeah, that's very useful. And I remember last month I lost my credit card, and someone picked it up and they used it, and they used the $300 in Target, and instantly I received a phone call and asking me if it's a fraud or not. And it seems that it was recognized by machine learning.
Yeah, that's also our goal, to detect that ASAP. Right now, like, it's still heavily handled by our operation team. So before the model is ready.
Okay. So anyone has questions? Please unmute yourself or raise your hand.
I think the audience with the name A, you are unmuted. You should be able to ask the questions since you raised your hand. Or you can also type your questions. If not, then I will start my questions personally. So I also use machine learning to study the protein drugs. So, but for me, the machine learning algorithm is still improving. And how do you think the accuracy of precisions associated with this current algorithms, or any other insights you can tell us a little bit more how to improve those algorithms?
Yeah, that's I think that's the key challenge to everyone who's working on machine learning. So yeah, that's involves so many domains, including like the data distribution, how you select the data, and how you normalize features, how you regularize your loss functions, how you design your architecture. Everything could affect the accuracy. But in general, I would say like, so it's based on experience. So for example, like for computer vision, like you sometimes like some certain filters can work. I mean, in a pre-neural net age, like you have different filters and different human generated features. Like some are effective in some cases, but some are not. And later on, like when we get neural nets, seems like it's an like the silver bullet to solve all the problems. But as people dive deeper, and turn out it's not true. So the neural net could be easily like hacked if you have seen like some adversarial image to try to trick the model. It could output some quite different label. So then like it tells like user like how can we use that in an actual case. For example, we onboarded to an autonomous driving case, and that could probably cause some safety problem. And this is really hard to solve. So like as far as what I know from friends at Waymo or Neural or like autonomous driving companies, they still heavily rely on human label rules to solve those corner cases. So that means like even though like those scientists have advanced the vision models a lot today, so there are still quite a lot real world problem or real world corner cases that hard to be like solved by just tuning the model. So I would say like today, like to reach optimal accuracy, you will need a hybrid solution. So either a mix of different models or like the human plus model. So that would be the optimal solutions. So that's also what we observed on in this big text recommendation systems.
Okay, I think this suggestions or insights pretty useful. Any other questions? I will give you the chance.
If no one have question, I do have one. So
go ahead.
I see a question. I see a question from the chat box.
Yeah, let's take that one.
Yeah,
and also we have Andy as.
Yeah, is it better to take math or computer science undergraduate major to study to study PhD or work in AI, ML? I think the audience is asking whether to take math or computer science.
Take both. I mean, it's not unseen, right? There are people who taking like major and minor, or pairing some of the math background with the computer science background. I do feel that, I mean, both are hard. Don't take that for like I'm giving you like an easy answer, but I mean, from what I heard, I think if you are interested in both, you probably want to at least take those courses. But Xiaochen can give more inputs, I guess.
Yeah, Chenxi, you added a very good point. My 2 cents is if it's not a hard blocker, if you just want to do computer science, be a software developer. So doing like writing code, the most important thing is not math, but the logic. As long as you are clearing logic, you can do very, very good coding. So I know many people coming from very far, like very different majors, like literatures, but they're still doing quite well. However, like if you really want to deep dive into AI or ML, it's you really require heavy like matrix computation. Like you need to know linear algebra good enough. So all of these are math. So yeah, it's up to you. Like if you want to further work on this, it's still highly recommended.
And I will be the host of today's talk, and my name is.
Yeah. So okay, we get more and more questions.
All right.
Yeah,
So the next question is, are you mainly or currently implementing ensemble techniques in those projects you have discussed? And what about the deep learning techniques?
So I think the question will be like, will I, as a research scientist, be the person who deliver the code change or the model change? Is that correct? If so, the answer is yes. So at least at Meta, like everyone is like in charge of his or her own area. So whatever idea you get, you don't have another developer helping you to implement those ideas. So you have to implement the model change, train the model, and deploy it online to measure the A/B test result. But there are some exceptions. For I know some scientists at FAIR, they do very theoretical research, and usually like we will have a team of engineers to help them to do to build the software to do those tests. But usually like because we are on the production side, so everything needs to go to the real product impact. So we have to implement everything.
I hope that answered the audience question.
Yeah, but feel free to follow up. Yeah, by texting.
Sure.
I also see one more one question above is like, have I ever seen more female scientists in AI field at Meta? Yes, that's true, and not only Meta, but all any other companies, even and also in academia. I think Kingsley also have seen that quite a lot. So it's great. I would say like finally like this year's like we are the the field of technology is more and more evolving, and we see more and more diversity, and this does like is really a good sign.
All right, I just saw that Andy raise your hand. Do you have questions? Feel free to unmute yourself and then ask the questions.
I think Andy raised her hand just by mistake.
Oh,
if you have question, yeah, please feel free to ask. So any more questions? Please don't be shy.
yeah.
Yeah.
If you don't, then
before
I
anyone
will,
get a chance, I can ask mine.
yeah, I
Yeah.
also have my question too. So
Yeah.
yeah, please take your chance. You are the priority.
Yeah. So Xiaoshen, earlier you mentioned about autonomous driving, right?
Yeah.
So like right now, except for like the corner cases, is there any other like major like roadblockers for like implementing full autonomous driving? And how much confidence do you have in the current like algorithms, the current like the firmware version that's implemented in like say Tesla cars or other autonomous driving cars? Like how far are we?
Yeah, very good question. Because our lab is like also do autonomous driving research, and many of my lab mates are not working in those companies. So I think I know some insight. So right now, the current stage, two major blockers. First is the scalability. We know like Waymo has done pretty good work in Phoenix and San Francisco, and they basically can handle whatever problems, whatever corner cases, and they have built a very good map. However, like what if they want to extend to suburban area, right? So usually like the way how today's L4 companies do is they have to send some cars there to scan a high definition map first before an actual car, autonomous car can be deployed. Then that comes to the problem. Can you map the whole US continent? That's impossible. So then like we have to somehow solve this problem, either on the model side, which can act as a real human, like you can handle new cases by just looking at Google Map. That will be challenging. On the other side is illegal. So if there's a crash done by the software, like whose responsibility it is. So we could say that, okay, by number, today the autonomous driving software can handle 99.9999% of cases. And then like, are people really comfortable with that if you are on that car? So, and also like, will the insurance pay for that? Will the insurance pay for that if that's a crash caused by a software? Like who's in charge of that fault? So it's still like, there's quite a lot of ambiguity there. And I don't think it will be like large scale applicable before we're solving that compliance issues. Yeah. But we do see some workaround on this. For example, we can deploy that instead of to pedestrian cars, we can deploy that to truck, right? And also we do implement that in a smaller scale. For example, let's do autonomous driving in an airport instead of the city roads. So that's is a very good first step.
Thank you.
Any other questions from the audience? If not, then I will also have one quick questions. You mentioned you have some internship experience. I wonder, will you supervise in those internship company, and how will we be like? For example, did you assign a project, or you work with other senior researcher, something like that?
Yeah. So I have four internship experience from undergrad to graduate. 3 of them are research focused. It's basically similar as doing a PhD. Instead of you have a different advisor, and the life will be very similar to what daily life of a PhD student, reading papers, doing experiment, and also the outcome is also a paper. And another one internship I did at Facebook, which called Facebook at that time, is about half research, half production. And that one will need you to not only coming up with the algorithm, but also need to ship that to production. So yeah, in that role, like I'm more asked for not only algorithm design, but also the lines of code I ship to the code base. Yeah.
I see. All right, so it's 6:20. I think we have a time to take one last questions. Let me see from the hands. Any other questions? All right.
Well, I can ask question if no more question from the audience. Right now, the machine learning has been utilized in every field in academia, in chemistry, in astronomy, physics. So, and there are increasing number of students, especially PhD students, are utilizing machine learning in research to build models to make predictions.
Yeah.
I am one of those, but I'm researcher in university. So, do you think would there be excessive number of people who are in the field of machine learning? Because in just a few years, all those students may go to the job market to find maybe machine learning jobs.
Yeah, good question. Like I started to observe that before I graduate. Yes, so there is definitely a bubble, not only in academia but also in industry. So especially in academia, like many papers are just published because they adapt some machine learning models on some field that's never used AI before. So they got a lot of papers and fundings. So I would say that's good. But like it's after this round, like those researchers will lack the ideas like what to do next. So except they have some theoretical or fundamental innovation. So I think that's the actual like challenging part, and we will see that soon after this round of like paper. I won't say paper spam, but it will like tons of papers. And on the industry side, yes, we are also observing like when we recruit every year at Meta, we are seeing more and more students, new grads coming looking for machine learning engineer jobs or like whatever machine learning related projects. So that's a good sign. And but like we also observe like many students, they really don't have the like very solid knowledge in machine learning. So they want to pursue some related experience, but actually they are not quite prepared for that. And on the demand side, it's still not overstaffed. So every field, every area in today's world needs a lot of machine learning. Expert machine learning engineers, not only in internet, but also in all traditional industries like transportation, like in agriculture and finance. So those super old systems need advanced technology to be changed to make them more efficient. And we are seeing like more and more engineers are coming out of internet industry and going there. That's a good sign. So, but right now I feel like internet industry is a little overstaffed with this machine learning titled engineers.
Thank you. Yeah, one last questions just from the audience. What area AI is most close to commercial profitability?
It's not close, it's already profitability. What funding Meta and Google is the recommendation. So the ads, search, and the general feed recommendation, all these three. You can see like today's big players, TikTok, Google, Facebook, Amazon, the e-commerce, they are basically based on recommendation. So all this recommendation AI, you can call that, or models, they are making real profit, they are making money. And for other fields, such as autonomous driving, we do see there are some good use cases, such as those autopilot is helping Tesla to sell cars, although it's not that advanced according to the whole industry. but it is making profit. Like recently, there is some generative AI used in both the natural language and also painting, generating like pictures. There are also some ways to making profit, and I saw many startups are working on it. So yeah, I would say all of this. Oh yeah, another big area is if you go to East Coast, all the like fund trading companies, they are all of them are using machine learning. So that's how like Wall Street is making profit today. It's yeah, they are heavily rely on machine learning to make profit.
All right, thank you, Xiaochen. I hope everyone learned something from this talk. And so very quick last question. Do you have any suggestions to our younger generations who will want to join this field?
Yeah. So I would start from my own experience. So my bachelor degree was not computer science; it was electronics engineering. So I would say recommend any younger generation, like our high schoolers. So just be there to make change to our own life. So I changed the major, like from undergrad to graduate, where my parents are not understanding that, because they think, okay, if you continue with this major, you can go to much better schools like MIT or Stanford with this major. But at that time, I think, okay, my interest changed to doing more software side. So I make that change. And also like similarly, like when I graduate, I didn't pursue the academia, but the industry, also similar mindset. So I'm responsible for my own choices, and I won't regret that because that's my own life. So when you are making such critical decisions, listen to your heart and don't. You can listen to others' opinions, but it's you to make the final decision, and you are the only one get the result of it. So just dare to make change. And also, the tech industry is a fast changing. One of the fast changing domains. So be prepared to shift priority every 2 or 3 years. That's very normal. Don't be upset, but just keep yourself updated.
That is a great suggestion. And I think that happened to me as well. I also changed my major when I started PhD. Okay, so thank you, Xiaochen. I would like to thank our audience for attending today's Ping Talk session. And CESAC will be having more events coming up. And Chenxi, can you give us some more updates on that?
Oh, I see that.
Yeah, by the way, this is the typical table that Xiaochen has on his desk.
You see the headset right there. I was muted when I was talking, but yeah, we asked Xiaochen to send us the picture of like his working environment. So if you like gaming, you probably like this environment. It will be coming easier when you switch from leisure to work. Yeah. So I would like to thank Xiaochen for giving us the feedback on his on the field, and especially on his final words for the experience, because that's why we are taking time to do the Ping Talks, because we heard so many stories about people regretting taking this major, or they didn't know what they're getting into. So you should really, we encourage the students to really understand what they're going into and take time to learn from, get firsthand information, and try to find your interest, because that's what's going to sustain you in the next like decades of work to do. And you're going to take that responsibility for yourself and just dive into what you love. That will be, this is the last session of the first season of the Ping Talks, but we will start another season of Ping Talks later, starting I think early next year. So if you are interested in any of those topics, please do let us know, and you'll see my email at the end. I'll show you later. But as for the upcoming events for CESAC, we will have another STEAM seminar. In 2 weeks, there will be Dr. Jonathan John's seminar about viewing the Earth from space. He has a 12-session STEAM seminar series that's going through the entire year, one per month. So next one will be December 17th. You will be able to take that from, you can take a screenshot and or you can follow us on our WeChat channel and join our email list so that you don't miss any of the events. Another we do want to bring up is that this is the end of the year, and this is typically the time that we start the application process for the CESASC scholarship and also the CESASC STEM essay contest. This year we're going to have a CESASC STEAM art contest as well. So do follow us on WeChat. I'll show you the QR code at the end. At the same time, I think there are someone who asked a question about how to get a transcript of the event today. So CESASC also have a YouTube channel. So if you go on to YouTube and search for CESASC, CESASC, you'll find our YouTube channel. We just started. You'll find all the Pin Talks events recording there. And at the same time, you will also find the, we'll do a Chinese version of the transcript of each of the 4 sessions. We're going to post them on the CESASC WeChat channel. So that's that. Please, you can also type in the chat box about like what other professions you're interested in. We'll invite speakers for season 2 based on your feedback. I didn't have the link there, but you can just type in the chat box if you're interested. And also I want to bring up that CESASC is a nonprofit organization, and our team are all unpaid volunteers. We couldn't have come this far without our generous institute and individual sponsors. If you're interested in donating to CESASC, please let me know. My email address here, terry.guochenxi@gmail.com. And that's that. And I'll park on this page and call it a day. You'll find our CESASC YouTube channel here, the WeChat channel. We also have the WeChat group where we're gonna post further events there as well. So that's what we have. And thank you guys for attending. And thank you, Xiaochen, and thank you, Kingsley, for making this event happen. I'm gonna see you guys in 2 weeks.
Thank you.
Thanks, Chenxi. Thanks, Kingsley.
Yeah.
Thank you very much.
Yeah.
To all.
Thank you, everyone.
We'll park here for about a minute or 2 before we stop the meeting.
And Chenxi probably can add me to the WeChat group, if not yet.
For sure. Oh yeah, Jim.
Yeah, thanks.
Hi, Xiaochen. I just want to say hi. Hi, I'm Xing. I'm also like right now. I'm also like a PhD candidate at USC. So I'm basically like a couple of years under like you. Yeah.
Oh, nice. Cool.
Yeah.
Let's
So
see the alumni.
yeah. And we are actually so right now I'm working on haptics, which quite relate to Meta's like reality lab and like this metaverse like concept. So yeah, I just want to say hi. Yeah.
Great. Yeah, sure.
Yeah.
So yeah, maybe we can talk more like on WeChat when if both of us in the group.
Okay.
I'm recruiting
Yeah,
Shane into the CESAC team. So he's the host of the previous
Oh,
version.
nice.
Another talk. Yeah.
Great. Cool.
Thanks,
Yeah,
Terry.
let's chat more.
Yeah, let's chat more. Yeah.
Yeah, Jixing, I think that's it. I'll stop sharing and we can stop the event here.
Okay. Everyone, bye. See you in our next Pin Talk.
See you guys.
Bye.
Bye, everyone.